Today is going to be 1-3 function compositions. And so today we're actually going to find the composition of functions. Now this is continue on with our calculus review, and we're just going to be in the unit of functions. Now if you remember from pre-calculus, function composition was a new way for us to be able to combine functions together. If there is an input-output process to every single function, you plug something in, you get something out. The idea of function composition is that the function itself becomes the input. So the composite of g and f, denoted g of f, is defined by the formula g of f of x equals g of f of x. So those are the two ways that you can visualize it, and they're both the same, provided x is an element of the domain of f and f of x is an element of the domain of g. So the domains have to be consistent with each other as you go through it, right? You can't have any undefined values at any level of it. If you do, you just have to make sure that it is then labeled. So looking at this graphic here, if you notice the way that it looks like I'm taking x, I'm plugging into my f function. Whatever I get there, I take my f function and I plug that into my g function. That's why it shows that my f of x is my input. And so the process going from here to here is g of f of x. That's why we use that symbology. Now visualizing a function composition even further, if I examine this example here, f of x equals 3x plus 5 and g of x equals x squared. When we say f of 5, what that means is I'm taking 5 and you plug it into the f function. Well, I have an f function here and I have a g function here. That's how I know which function to plug it into, is because this letter identifies that function. So it says plug 5 into my f function. So I'd plug 5 into here, and so I'd get 3 times 5 plus 5, which is going to be 20. If I wanted f of x plus 2, well then I'm taking that x plus 2 and I'm plugging it in for x into my f function. And so that's how I'm going to get 3 times x plus 2 plus 5. But then if I wanted f of g of x, in this instance, now I'm taking my g function and I'm plugging it in for x into my f function. And so the way that that would look like is I'm taking this x squared and plugging it in for x. And so that's how I would get 3 times x squared plus 5. So let's work with a few of these. So I defined 3 functions here, f of x, g of x, and h of x. It says just find the indicated value. So in this instance, it says take 1 and let's plug it into my f function. So my f of 1, that's going to be 1 squared minus 4 times 1. So I get 1 minus 4, which is negative 3. So now I need to take that value, because another way of looking at this is g of f of 1. I plugged 1 into f. Now I need to take this and plug that into g. And so I need to take this negative 3 and I need to plug that into g. And so I'm going to get g of negative 3 equals 2 minus the square root of negative 3 plus 3. 2 minus, that would be root 0, so I get 2. So I can say g of f of 1 is going to equal 2. Next example. This one says take 1 and plug it into g. So if I take 1 and plug it into g, I'm going to get g of 1 equals 2 minus the square root of x plus 3. So plugging in 1, that's 2 minus 2, so that's going to be 0. So g of 1 is 0. So now I'm going to take that 0 and I'm going to plug it into my f function. And so plugging that into my f function, I'm going to get basically just what f of 0 is, and in this case that's going to be 0 squared minus 4 times 0, and so my answer is going to be 0. So f of g of 1 equals 0. Now let's look at these a little bit more abstractly. Because I plugged in 1, it actually kind of makes it a little bit easier. But what if I don't plug in 1? Well, this is just saying x into f. Well, x is already there, so I don't have to worry about it. So now I have to take my f function and I need to plug it into g. Now the other thing that it's asking me to do is state what the domain is going to be. So plugging my f into my g function, well, let's start with my f. My f is x squared minus 4 times x. And I need to take all of that and plug it in to where I see x. So this is going to give me 2 minus the square root, there's a placeholder here, plus 3. And I'm plugging in f of x into here. And so because we said f of x is x squared minus 4x, I get 2 minus the square root of x squared minus 4x, and then I get plus 3. Now I need to find the domain. So we went over there's 3 major domain restrictions. First, is there a potential for me to divide by 0? Well, in this case, no. The second, we said that you can't have a negative value inside of the square root. Oh, I have a square root. So I have to isolate what's inside the square root, x squared minus 4x plus 3, and I need to say that that's going to be greater than or equal to 0. Now because this is a quadratic or a polynomial inequality, I'm going to have to create that number line, and we have to do the whole above or below thing, or in this case, because this says greater than 0, I'm looking for positive values. So we need to find the zeros. So this factors into x minus 3 and x minus 1. And so that's going to give me 1 and 3 because it's equal to, they're both solid. And you have to test values. Well, if I plug in 0, negative 3 and negative 1, well, negative is positive. If I plug in 2, you're going to get a negative. And if I plug in 4, that's going to be a positive. So my solution is here. So this right here, this is my g of f of x. And then my domain is going to be from negative infinity all the way to 1, union from 3 all the way to positive infinity. My next one, this one says f of g of x. So now I'm taking the g and plugging it in. So same idea here. I need to imagine this having placeholders. So if I'm taking my g and plugging into my f, with my f function, I need to imagine like there's placeholders. And what I'm plugging into this is my g function. So plugging in my g function, I'm going to get 2 minus the square root of x plus 3 squared minus 4 times 2 minus the square root of x plus 3. Now just for this instance, yes, you can simplify it. I'm just going to leave it like that just to kind of save time on the lesson, but we still need to examine what my domain is going to be. And so we're not dividing by 0. I have something inside of a square root, so I need to restrict my domain in that instance. And so even though this right here, this is now my f of g of x. Now my domain, I need to say that this, so that x plus 3 has to be greater than or equal to 0, minus 3 on both sides, so I get x is greater than or equal to negative 3. And so this is going to have a number line. Here's negative 3. X is greater than that. So my domain is going to be from negative 3 to positive infinity. Next one, we have g of h of x. So I'm going to take my h and plug that in for g. So I take my h and I plug that in for g. And so I'm going to get 2 minus, now my placeholder was x. That's where I need to plug in my h of x. So that's going to be 2x over x plus 1. So there's my composition without writing all the formal notation there. But now I have to once again find the domain. And so this is where it gets a little tricky because now I have 2 restrictions. The first, that has to be positive. And then the second, I'm dividing by x plus 1, so that cannot equal 0. Well, that one's easy. X cannot equal negative 1 if I subtract 1 on both sides. But now I have to find this one. So I have to subtract 3 on both sides. 2x over x plus 1 is greater than or equal to negative 3. Multiply both sides by x plus 1. I get 2x is greater than or equal to negative 3x minus 3. and that gives me 5x is greater than or equal to negative 3. Divide both sides by 5. I get x is greater than or equal to negative 3/5. And so in this instance here, we have to look at a number line. So I'll draw that number line here. We said at -1, that has to be an open circle because we said it can't be that value. And then we have negative 3/5, which just so happens to be right here. That has to be a closed circle, and we said that x is greater than that. And so all of that is going to move there. Now you're probably thinking, wait, didn't I divide by negative? No, I didn't divide by negative. I divided by a positive number. It just so happens that the number is negative. That's okay. And so my domain is going to be from negative 3/5 all the way to infinity. As long as I plug in those values, it will work. Next one, take my h function and plug it in for h. So I get 2 times 2x over x plus 1 over 2x over x plus 1 plus 1. Now once again, yes, you can simplify this even further. I don't want to spend that time on it. I'll just briefly simplify that to 4x over x plus 1 over 2x over x plus 1 plus 1. Actually, you know what? I'll do that. I just won't worry about the domain in this instance, because I know some of us probably need help doing these complex fractions. So in this instance now, I've just multiplied the 2 through, so that's okay. But now here towards the bottom, how do I combine those together? Well, I need to find the common denominator. And so if there's an x plus 1 here, this needs x plus 1 over x plus 1. And so now what I'm going to have listed is I'm going to have 4x over x plus 1 over 2x plus x plus 1 over x plus 1. So now combining like terms, I'm going to get 4x over x plus 1 over 3x plus 1 over x plus 1. Now those cancel out, so I'm going to get 4x over 3x plus 1. And so that's going to be my simplified composition. Now remember, you'd still have to find the domain in that instance. So what is it that we reviewed today? Well, we took a look at a composition of two functions, and we reviewed a little bit of domain, and we reviewed a little bit of how to simplify complex fractions. So in your own words, I want to give you a little bit of feedback. I want you guys to describe the composition of two functions to me. Well, this does conclude our lesson. If you have any other questions, please leave them in the comments.